Alright, you guys, so you should have received a yellow, just blank sheet of paper. And you're basically just going to make a graphic organizer with this, similar to what we did for 4A. The difference is you will get the formulas, so it's not like you need to write the formulas on a note card or anything this time, so you're not going to get a note card, but you do need to create a graphic organizer to use as a study tool to kind of know what all the concepts are in this unit. So first thing is, once you get your graphic organizer sheet, the blank paper, you're going to take your yellow paper, let's just say it looks like this, and you're going to fold it twice so that you have 4 squares. So just like we did for A. So you'll have 4 squares. You'll have 4 squares on the front, 4 squares on the back. So the first top two squares, so these top 2 right here, we're going to do those first. And the top 2, I kind of blanked out some stuff, but the top one will be area of sector. Ooh, that's really thick. So let me make sure I change my point. Alright, so basically you're doing area of sector and arc length. That's going to be our first box. That's how we started the unit off. And you want to go ahead and just draw this example really quick. So we have a circle here that has a central angle of 150 degrees and a 7-inch radius. And we want to first find the area of the shaded region. So if you need to pause, draw the picture, and then go ahead and hit play, and we'll go ahead and do the work together. Notice I kind of left the answers there for both of these, so we should know what we should get in the end. But the point is, we just got to make sure we have an example of each type. So go ahead and first pause, get the basics written down, and then we'll put the fill in the work that you can kind of see I blanked out. Alright, so for the area of the shaded region, we are looking for basically how much space will fit inside of that shaded pie piece right here. So to do that, remember there is a formula that we can use. And I'm going to make my pointer just a little bit smaller. See if that work. Yeah, that's good. Alright, so basically remember the formula is that you do the angle measure, which we use theta, divided by 360, because that tells us what piece of the pie or the circle that we're actually finding, times the area of the entire circle, so times pi r squared. And from there we can go ahead and substitute in everything we know. So we know the angle measure. We know the angle measure is 150 degrees divided by 360, and then we're going to multiply by pi, and our radius is 7 inches. So pi 7 squared. So if you go ahead and calculate this, you should see in your calculator that you get 64.1 inches squared. So that is just review of what we started with the unit. And remember that formula for area of a sector is given to you. So it's just showing, basically you showing us that you know how to use the formula. Alright, so the second formula we dealt with in this unit so far, no, it's not the area inside the pie piece. It's basically how long the arc is around the edge of that pie piece, kind of like the crust. If this was a pie, we're trying to figure out how long the crust should be right here in this spot. So to do that, remember there's a formula for that too, and it is given. You do the angle measure divided by 360 times, well, we're finding a piece of the circumference. So the fraction represents the piece that we want, times the circumference formula, which you can use 2 pi r, or you can use pi d, so whichever one you prefer. But once again, the formula is given on the formula sheet. It may look a little different, but it includes all those parts. So now if we fill everything in like we've done, we're doing the 150 degree divided by 360, and then we're multiplying by 2 pi, and our radius again is 7. So once we calculate that, we should get 18.3 inches. So just have those two on in your first box of your graphic organizer, so you have an example of area of the region, which remember is called a sector, and length of the arc, or arc length. So that's just an example of how we started the unit. So on box 2, I wanted to show an example of composite area. Composite just means two different shapes put together. So we want to find the area of two different shapes put together. So as you see, it says find the area of each part, then add. So that's basically just telling us what to do. So we need to find the area of the two separate parts and then add. Well, notice I'm pointing to the top here. The top is a half circle. So half of a circle, we're going to go ahead and find the area for that half a circle. Well, first off, we know that the circle area, the formula for the circle's area is pi r squared. Once again, that's on the formula sheet. So if we find the area for the entire circle, after we find it, we can then simply just divide by 2, and then we'll have the area of just the half a circle that we need. So let's go ahead and find the area of the whole circle by doing pi times your radius, which is 3 squared. Now notice I put 3 because you should recognize I gave you the entire length across, which is your diameter, so you do need to put 3 in for your radius. Once again, you should pause as you go through this to kind of try to do it yourself. And so that way we get 9 pi as our exact answer, which is approximately 28.3. And then the key here is to remembering that you do need to divide by 2 in order to just get half the circle. So if you divide the 28.3 by 2, so 28.3 divided by 2, you will get 14.1. Now remember, this is not your answer, but if this was multiple choice on a EOC, they're going to have this answer there. You got to remember that all you found so far was really, should not do that, is really the area of half that circle. So now don't forget you have a second shape here. You have a triangle right here at the bottom. So basically it's just two problems in one if you really think about it. And then you just add them together at the end because you have half a circle and you have a triangle. So on the formula sheet, once again, we have the area of a triangle. So it gives us the area of a triangle on the formula sheet is 1/2 the little base times the height. So remember, little b just means like the bottom of the triangle if it was sitting upright on its bottom. And then h is just the height of the triangle. And it has to be the little b and the little h have to be the two legs that form basically like a 90-degree angle. If it's going to be, it has to form a 90-degree angle somewhere. Even if it was a triangle that went out like this, your bottom would still be the bottom here, the part that would be sitting up, and then the height would be now in the middle of it. So it's just wherever you find that 90-degree angle, because whenever you measure height, you go basically from, if you imagine this flipped over, you'd go from the top straight down. You wouldn't go from the top out to the side. So make sure it makes sense as a height. Alright, but let's do the problem that's here. So if we substitute in everything we know, we have that the area of the triangle is equal to 1/2. Well, the bottom of the triangle, all the way across of the triangle, is 6. The height, remember we gotta think of this kind of flipped over, is 10 inches. So if we go ahead and multiply that out, we get 30 inches for the area of the triangle. So now we have our two areas, so all you do is simply add. You found one, you found the other, now you just add them together. So we got 14.1 plus 30, and that's going to equal 44.1 inches squared. So that would be our final answer for the composite area. So remember, composite, that just means two or more figures put together. So basically you're just adding once you find them separately. Alright, so that's your first two squares. So let's move on to the bottom two squares. So now I'm going to do these two. Now these two, here's the title. We've done both of these already as well, so nothing new so far. I just want to make sure we have it all in one place. So we're doing our sphere volume first. Remember the volume of the sphere formula, so take time to pause and just draw what's here before I talk about it, but I'm just going to keep talking because you should have paused. So the volume of a sphere formula is on your formula sheet, but remember it's volume equals 4/3 pi r cubed. So remember, it's on the formula sheet. So, I just kind of put this little note here to remind us it's on the formula sheet. So we can go ahead and find it just to have an example on our formula sheet that the volume is equal to 4/3 pi r cubed. So r cubed. So we're putting our radius in. Notice that they give us our diameter. So we have to divide by 2 to just get the radius. Remember, the radius is half of the diameter. That means that the radius is 6. So 6 cubed. And now we can go ahead and calculate the exact answer. Volume equals 288 pi, and which is approximately 904.8 inches cubed. So that is our volume of our sphere in both exact and approximate answers. So as you see towards the bottom, I just put a note here. I don't think we necessarily need to do an example of it, but just include a note on your graphic organizer that half of a sphere, all you do, once again, it's called a hemisphere. We talked about that in class, but all you do is divide the volume by 2. So once you get the volume of the entire sphere, this is just a reminder that you then divide the volume by 2. All right, so just include that note on your graphic organizer somewhere. So for the fourth box, you're going to go ahead and put your prism and your cylinder volume in there. So we're just going to do a problem or 2 problems where we're using this big B concept. Remember, this is huge that you understand what big B is. Remember that big B, this big B in the formula, because the volume equals big B times H. That big B is the area of the bottom or base of the entire prism. Or in this case, cylinder would be, the bottom would be shaped like a circle. So you're finding the area of that base shape. That's what big B is, the area of the base shape. It is never, big B is never a number you can just get off. So it's none of those numbers. So if you're putting a 3 in for big B, or 4 in for big B, or 8 in for big B, those are all wrong. All right, so make sure you're calculating big B. So first things first, and obviously this is what this all says right here. But first things first, let's go ahead and find our big B. So identify the shape of the big B. So our big B, and I would include this on your graphic organizer. So big B is a triangle. Let's just make sure we note that. So therefore, we need to use the triangle formula. See if I can erase this. Ooh, I erased that too. That's all my hidden stuff. Alright, so try to scratch that out a little bit. Alright, so basically we're gonna go ahead and use the triangle, the area of a triangle formula. So the area of a triangle is equal to 1/2 little b times h. Remember, that's on your formula sheet. So that's 1/2. Well, if you look at that triangle down there, you have this side and this side that form the right angle. So therefore, we're going to use the length of these 2 sides as our little b and our h. Now, yes, you don't have those down there at the bottom, but notice that the triangle at the top, it has the same 2 side lengths. So if this short one's 3, then that means that the bottom one's 3. If this longer one's 4, that means this one's 4. Because remember, it's a prism, so we have the equal lengths on the bases. So we're going to use 3 and 4 is our little b and our little h. So when you do that, you get that so our big B to B is equal to, if you just multiply that out, we get 6. So therefore, we're going to use that and put it in place of our big B right there. So in our volume formula, we're going to have volume equals our big B, well, our big B is 6, times, all it is now is times the height of the prism. So the height of the entire prism is 8, it's an 8, and that's going to equal 48 units, because we don't really have any inches or anything on this one, units cubed. So whatever the units are, we cube. So that is our final answer for our volume of our prism. So make sure you identify what your big B shape is. Find the area of that shape. And then after you find the area of that shape, that becomes your big B. And that's what you put in the formula as your big B, and then you just multiply it by the height. So this little baby formula right here, that's the only one not on your formula sheet. The one for the area of a prism. So make sure, you just kind of get familiar with that, the smallest formula there is for volume, which is big B times H. All right, that's the same formula you can use for a cylinder, although the one on the formula sheet for a cylinder, it's a little bit longer, only because it replaces the big B with the circle area, which that's what you're doing for big B, because the bottom is a circle. So if we use V equals big B times H, we basically are doing that the volume for this cylinder is going to equal big B times H, or in this case our big B is a circle. So the area of a circle formula is pi r squared, which equals pi. In this case, if you look at our r, the radius right there is pointing to is 5. So 5 squared. And then that's going to give us 25 pi. So hopefully you're including this on your graphic organizer. And now we know our big B. So now we can go ahead and do volume equals our big B, which is 25 pi, times the height of the cylinder, which is 10. So now that's going to give us 250 pi inches cubed as our answer for a cylinder. So once again, the point of this is to have an example of each type on your formula sheet. That way you have something to refer to that has everything from the unit on there. And really, like I said, this should be a great unit for you guys if you just really get this stuff down pat. All right, so that's the first 4, so flip it over. The next 4 we're gonna do. These will be a little bit quicker because you can kind of get the gist of it. They're all using the formulas. So let's go ahead and look at the cone and pyramid. So pause me if you need to, so you can go ahead and jot down the images before I talk about them. All right, so let's go ahead and do the cone. So notice that since you're doing a cone, and remember for anything that comes to a point, so like the cone or the pyramid, anything that goes to the point, you're having to do the 1/3 times the big B times the H. So you're going to do 1/3 times big B times H. This is on your formula sheet for a cone or a pyramid. So let's go ahead and knock it out. Notice that your big B here is a circle, so your big B is equal to the area of a circle, a small little shape of a circle. So the area of a circle, if you look at your formula sheet, is pi r squared, which in this case is pi. Well, our radius is 2, so pi 2 squared, which is just equal to 4 pi. So that's our big B. So now if we substitute that into our formula, we have that the volume is equal to 1/3 our big B, which is 4 pi, times the height of the cone, which notice that the height right here, they have marked at 5. So that is equal to the exact answer of 20/3, or 20 to 20/3 pi inches cubed. So that is our final answer for the volume of a cone. All right, so now to move on to the pyramid, just so you can see it's really no different than the rest. Have that example in there too. So in this case, our big B is a rectangle. So the area for a rectangle is equal to length times width, which is the same thing as little b times h, so base times height of the rectangle. And it looks like a square, but if you really look at it, the side lengths aren't the same. This is 2 and this is 3, so it's actually a rectangle. So here's our base shape, which is a rectangle. So our little b and our little h, remember, have to come off of that rectangle. So it has to be the 3 and the 2 because it's the side lengths. So we're basically doing that the area is equaling 3 times 2, which is equal to 6. So our big B is 6. So now if we put it in the volume formula, remember you're not done, but if you look at your answers too early, you may see a 6 over there and may try to grab it, but we didn't find the volume yet. So the volume equals 1/3 our big B, which we just found to be 6, times the height of the actual pyramid, which notice on the side here they have the entire height of the pyramid equal to 6 centimeters. And that is going to equal 12. Since we're doing volume, it's going to be centimeters cubed. So that is our final volume for our pyramid. Alright, so for a composite volume, so notice on this one we did composite area, so we just used 2 area formulas. Well, for composite volume, it's a 3D image, so we're going to have to use 2 volume formulas, and then we're just going to add them together at the end. So if you notice, you have 2 figures here. You should see half of a sphere, so we have a hemisphere at the top, and then we also have a cylinder. So the first thing we need to do is go ahead and find the volume of that sphere. Well, remember, we're going to find the volume of the entire sphere, but then we're going to divide by 2. So that we only have half of the sphere because it's a half a ball sitting up there at the top. So first things first, the volume of the sphere, remember, is equal to 4/3 pi r cubed. So if we do that, we have 4/3 pi. The radius in this case right here is 3. And then that is cubed. So we end up getting 36 pi for the entire sphere's volume. But remember, it's key that we put this as a note, to divide by 2 for half the sphere. I'm just going to kind of put a little sphere right there. That don't look like a sphere because it kind of doesn't, but you can put hemisphere. Alright. So make sure you include that as a note. So to do that, we're doing 36 pi divided by 2. That's going to equal 18 pi. So our sphere volume is, our hemisphere volume, is 18 pi. We're going to need that. But we cannot forget we have a second figure here, which is this cylinder here at the bottom. So we have to find the volume of this cylinder at the bottom. So our second one we're going to do is the volume of a cylinder formula. So that is equal to, if you look at your formula sheet, you could use the one directly on there, or you could use the big B, but all big B is a circle, so it's pi r squared. So the volume of a cylinder is on your formula sheet. So our radius, once again, is 3, so pi r squared. And then times the height of the cylinder. Well, if you look on the side there, right here, it's showing you that the height is 5. And so you get that the volume of the cylinder is 45 pi. So remember, all the formulas are on the sheet that you need. You just got to know how to use them. So we have our volume of our cylinder. Remember, if you look too soon at a formula sheet, you may think you have your answer. But now we have the 2 volumes we need, and we need to add them together. So really, we need to make sure we remind ourselves to add them. And so we're really doing the 18 and 8 pi plus the 45 pi. And then we should get that equals 63 pi. And then we don't have any particular units, so we can just put the word units cubed. So that's our final answer for our composite volume. So the key here to know is whenever you have 2 volumes stuck together, you find them separately and then you just add. Don't make it rocket science. Alright, so the last 2 boxes on the back, we need to talk about cross-section a little bit. So a cross-section is just basically if you took a, almost like if you sliced the figure in half, or down a side or along a side, if you made a slice, what would the shape be if you opened the figure up and looked at it? So in the red here, I'm showing where we're slicing. So this, you imagine like a piece of paper that's slicing the cylinder right here. Well, if you were able to separate the top part of this cylinder with the bottom part and you opened them up and looked at it, you should see that the face of the slice would be a circle still. So the cross section in this case would be a circle. If it was a horizontal, notice this is a horizontal slice. Now, if I just look at the cone at the bottom and I slice this cone vertically, so a piece of paper would slice it right at the tip, right down the tip of the cone at the top, and then all the way down to the base. Well, if you really can't just kind of imagine this, because sometimes it's really hard, just think about where the paper would meet the cone. So we'd have this kind of shape going on here, and then it would meet the paper and the cone would meet here, and it would meet here. So you should see that it actually forms a triangle where it's slicing. All right, and then for a sphere, if you cut it with a piece of paper right in the middle, you should kind of see that you're gonna get a circle in the slice. So if you're able to pick up the top of the sphere and look at it, you should see a circle. And then lastly at the bottom there, I show you if we sliced a cylinder horizontally, if it was laying on its side, if you imagine picking it up and looking at the face of it, you should see that you would have a rectangle, and the rectangle would be right here. If you're actually able to see the other side, it would be like that. But so the cross section is a rectangle. So notice you can cross things vertically, cross them horizontally, so you will end up practicing this whole cross section idea on Friday. Just kind of see if you can kind of get the gist of what the cross section would look like either way. So the very last one that I left blank is called Cavalieri's Principle. So we're going to do that one really quick. And it's just kind of like a note, but you got to understand the note. So let's go ahead and title this one Cavalieri's Principle. All right. So basically, Cavalieri's Principle just lets us know if we have two solid figures with the same height and same bases. Sometimes they refer to the base as the cross section because the cross section shape will be the same as the other cross section shape, which will be the same shape as the base. Maybe just different size depending on if it's a cone or not, but same base or cross section. Then their volumes are the same. Alright, so make sure you have this note and I'll kind of explain what it means really quick. So make sure you pause me if you need to go ahead and write that. So two solid figures with the same height and same base. Two solid figures with the same height and same base. Ooh, we should need to word that ending differently, huh? It doesn't read very well. We just need to put have the same volume. Have the same volume. All right. So now to explain it. So basically what this is saying is if you have a cylinder that is sitting upright like this, and we know that the radius is 5, so the radius is 5 at the bottom, so basically the base is a circle with a radius of 5. And let's say we know the height is, I don't even need that since it's straight. Let's say the height is 12. Well, that volume that you're gonna get is gonna equal the same volume as if I took that cylinder and I kind of pushed it to where it looked like that. So if I pushed it over to where it was kind of slanted now, but it had the same radius down there at the bottom, so it has the same size base, and the height of it, no matter that it's slanted, if I measured the height, if the height was still 12, then those are going to have the same volume. And that's because if we just focus on this slanted one right here, the volume is still going to equal, let's say, big B times H, because it's a cylinder, so the base is a circle, so the big B would be a circle, which the area for a circle is 1/2. Oh, excuse me, not 1/2, it's not a triangle, is pi r squared. So we know the radius is 5. No matter which cylinder we're looking at, the radius is 5. So no matter which one you were doing, you would be putting 5 in for the radius. And that's going to equal 25 pi. Now, when you plug it into the volume formula, the volume equals our big B, which is 25 pi, times the height, no matter, once again, which cylinder you're looking at, the height is 12. So either cylinder you're looking at, no matter if it's slanted or not, they're going to have the same volume if they have the same size base and the same height. So that's going to equal 300 pi. No matter which cylinder you're looking at, they'll have the same same volume. So just make sure you have that as a note. It's kind of like a fact you need to know, whether the cylinder or the prism, no matter what it is, if it's the same size base and the same height, you're going to have the same volume. Same volume. I didn't say same anything else, but same volume. All right, so go ahead and do your classwork. Keep this graphic organizer on you because you'll need it tomorrow especially. And then, yeah, be ready because that's basically the whole unit on a sheet of paper. Good luck and don't do anything crazy because I'll be back.